Hello everybody. Welcome to this lecture on addressing used in networking. So in our previous video we had discussed about the concept of layering and the various layers in the OSI model. So we had looked at the layers in OSI model, and we had also discussed about the different types of deliveries that are considered or that are implemented in the different layers. Like, say for example, in the data link layer, we have hop to hop delivery. So the data link layer is only responsible for hop to hop delivery. Similarly, the network layer is responsible for source to destination delivery, and the transport layer is responsible for process to process delivery. So let's see what this means. So here I have some machines. Okay, this is, say, connecting these three machines. This is one LAN. Then I have a router here which is connecting me to another LAN out here. Okay, so this could be, so this is a router. The other two here, these two can be either switch or let's say, okay, let's consider this to be a switch. This is also a switch. Okay, and the ones here, these are the end devices. So this is, say, this is a computer, say A, computer B, and computer C, and this is again another computer D, E, and F. Okay, so here I have, this is one LAN, this is, say, LAN 1, and this is another LAN, LAN 2, and both of these are connected by the router here. So in the data link layer, the data link layer is responsible for sending from a hop to hop, so from A to the switch here. So the data link layer will be responsible for this. Similarly, from this switch to the router, this is another, this is between the data link layer of the switch and the router. Similarly, here and here, and then let's say the destination is device E, so from here to here. So this is the entire data link layer, how they will work, hop to hop. The network layer is responsible for transmission from the source to destination. So A is the source, E is the destination. So the network layer would be responsible for this entire transmission from the source to the destination. And the transport layer is one level higher than that, that is in device A, there may be multiple processes which are running. Okay, so let's say process 1 is running and process 2 is running. Similarly, in device E, in the destination device, there may be multiple processes which are running. So let's say 3 and 4. So the transport layer is responsible for transmission from process to process. So process 2 is generating the data. So from process 2 of device A, okay, to process 4 of device E. So this yellow line that you can see is responsible for that is the work of the transport layer. So from one process to another process. So in order to perform all these different types of deliveries at different levels, whether it is hop to hop or source to destination or process to process, each of these will need some addresses, because until and unless an address is specified, there is no way the data can be delivered to the right place. So we have different types of addressings at different levels. So let us see what are the different types of addressings that we have at different layers. So let's start with the data link layer. So in the data link layer, we have an address which is known as the MAC address. So the MAC address, MAC stands for Medium Access Control. This stands for Medium Access Control. So here every machine or device in a LAN will have its own MAC address, and this MAC address is fixed. This is fixed. It cannot be changed. In fact, it is given by the manufacturer. This is given by the manufacturer of the device. All right. So you can see here, device A will have a MAC address. This switch will have a MAC address. This router will have a MAC address. All of these will have MAC addresses. Okay. So, and these are all fixed. And usually it is a 48-bit address. Okay. And remember, it is permanent. And this is also known as the physical address. It's a physical address. So it cannot be changed and it remains the same throughout. So when you remove, say if you want to remove the machine A from LAN 1 and move it to LAN 2, the MAC address of A will remain the same. Okay, so this is the MAC address. This address is used in the data link layer. So when a frame or a data unit has to move from A to the switch, this part when it has to move, then the source address would be the MAC address of A and the destination address would be the MAC address of the switch. Similarly, when it has to move from the switch to the router, it will be, the source would be the MAC address of the switch and destination would be MAC address of the router, and so on. So this is the MAC address which is given at the data link layer. Next we have the network layer. Above the data link layer we have the network layer. Now in the network layer we have source to destination delivery. So we need a unique address to identify A. Let me use a different color here to identify A and E. So every device in the network has to have a unique identification, and this is given by, in the network layer, by the something called the IP address. Okay, IP stands for Internet Protocol. Internet Protocol. So IP address is unique in a unique address. It is a unique identity for a device that is connected to the network. And here this is a logical address. This is a logical address because it can be changed. So again, when you want to move, say, the computer A from LAN 1 to LAN 2, you can change the IP address of the device. So it's a logical address based on where it is currently. So currently it is in LAN A. So here the IP address of the device A is say something. When we move it to say a different LAN, we can change it. So it's a logical address, and it is a 32-bit number. 32-bit number, and usually it is 4 octets, that is 8 bits followed by a dot, then another 8 bits followed by a dot, then another 8 bits followed by a dot, and the last 8 bits followed by a dot. Okay, so based on this IP address, the router can decide where to forward it to. So when in the network layer, the source address would be the IP address of A, and the destination address would be IP address of E. So this is at the network layer level. This would be the IP address is used at the network layer level. And finally, at the transport layer, we have here in the transport layer, we want to identify the process. So our process is process number 2. So within a particular machine, within a particular device, let's say A, I have multiple processes working. So which of these processes is sending the data? And at the destination also, there are multiple processes which are running. So to which process must the data be delivered to? So here also we need an address now for the processes. So different processes which are running in different machines has to be given an address. And this address, which is given at the transport layer level, this is known as a port address, also called port number. This is called the port number. Okay, so this port numbers can be both. It is neither fixed, nor it can be both fixed as well as dynamic. So if it is fixed, then in that case, certain processes, like say HTTP, like here in the hypertext, different protocols, they are running some of these they run at some fixed port numbers. So some port numbers are reserved for these processes. So those are fixed. So they are also known as well-known ports. Well-known ports. And for others, you can also assign it dynamically. Can be assigned. Can be assigned dynamically. Okay, so in the transport layer, the source address would not be only the IP address, it would be the port, say the port address of process 2, and destination would be port address of process 4, which is running in E. So the IP address will help you identify in a network, it will help you identify the device. The port address will help you identify which process inside, which is running inside that particular device. So here you have port address. Here you have IP address. And for this communication, you have the MAC address. So these are three different types of addresses that are used in networking in the various layers. So data link layer, MAC address; network layer, IP address; and transport layer, you have port address. One task I want to give to you is, from your machine, try to find out how you can try to see what command you have to give to find out what is the IP address, what is the MAC address, and what is the port at which some of your processes are running. Okay, so you run your browser and find out at which port this particular browser is working. So that is the assignment. So That's all for in this video. We'll meet again in the next video.